Welcome back to Maths with Mrs. J. Today's challenge isn't actually all that difficult, but because it involves a few interesting skills, I wanted to go through it with you. If you'd like to have a go first, have a go and come back and have a look and see how it's done. On the left-hand side, we have the cubed root of a linear expression. On the right-hand side, we have a square root. How are we going to proceed from here? Well, just bear in mind that the cubed root is the same as having an index of a third. The square root is the same as having an index of a half. If I raise both sides to the power 6, which is a valid thing to do, as long as we're careful and check our answers later on. So if I raise that to the power 6, what that's going to do is eliminate any fractional indices. So we're going to end up with x plus 3 squared on our left-hand side and x minus 1 cubed on our right-hand side. Okay, expanding a perfect square, we should be able to do that okay. So x squared plus 6x plus 9. Expanding a perfect cube, hopefully you're able to do that by now. That's x cubed minus 3x squared plus 3x minus 1. If you really get lost with that, you could just do x minus 1 times x minus 1 squared, which is x squared minus 2x plus 1, and just get your 6 terms and tidy it up. You should hopefully be able to go straight to here. All right, bring everything over the one side. So we get x cubed minus 4x squared minus 3x minus 10, and that's all equal to 0. Now, if we're wanting to solve this, we really want to find a factor first. It's going to be a little bit of trial and error here. So if we let p of x be our x cubed minus 4x squared minus 3x minus 10, and we're starting to try some values of x to see when we can make p of x equal to 0. 1's clearly not going to work. 2's not going to work. I think if we try, I think we're going to have to go up a bit here. So if we try 5, we're going to get 125 minus 4 times 25, so minus 100, minus 15, minus 10. Yep, that will work. So that's equals 0. So x minus 5 is a factor. So now we're going to do our division to work out what the quadratic component is, and maybe that can be factorised, maybe it can't. We'll have a look. So we're going to get our cubic here, x cubed minus 4x squared minus 3x minus 10, and we're dividing that by x minus 5, leading term divided by leading term, do our subtraction. So we get plus x squared minus 5x, and we get 2x minus 10 plus 2. Of course, if you didn't get a 0 remainder here, you'd know something had gone wrong along the way, because we just found that x minus 5 should be a factor, so we should have 0 remainder. So what we're actually getting here is that 0 equals our x minus 5 times x squared plus x plus 2. So obviously x equals 5 is a solution, which we will just double check in a minute that it's valid and that it works in both sides. This here, this quadratic here, let's think about solutions for that. That is not going to factorise. And if you work out the discriminant there, b squared minus 4ac, you're going to get 1 squared minus 8, which is negative. So that quadratic will bring with it no real solutions to that particular part of the situation. So the only potential solution we have is x is 5. Let's just check that that is okay. So if left-hand side, we sub in x as 5, we get cubed root of 5 plus 3, which is cubed root of 8, which is 2. That's all good. Right-hand side, we get square root of 5 minus 1, which is square root of 4, which is 2. So yes, that's all good. And that's in fact our only real solution.